The first exponent property is called the product rule, and I like to think of it like this. When the bases are the same, you simply write the base once and then add the powers. You write the base once and you add the powers. So here I have x to the power of a times x to the power of b, and note the operation between is multiplication. So I'm not looking for like terms, I'm looking for like bases. So I would write the base of x one time, and then I would add the powers together, a plus b. So if I had x squared times x to the fourth, I would write the base of x once, and then I would add 2 and 4 together. So this becomes x raised to the power of 6. And then let's look at the examples that are given on the chart. So here I have a base of h raised to the power of 2 times the base of h raised to the power of 6. So I would write the base variable once, and then I add the powers together. So in my simplified answer, that variable should only appear one time raised to the proper power that would represent how many times it appeared in the original expression. Let's look at number 2, where it starts to layer up just a little bit, but you still apply the same properties. It just looks a little bit more cluttered. So the first thing I'm going to do is deal with my coefficient. I have negative 2 times positive 7, so my coefficient is going to be negative 14. I'm going to write the base of a one time, and I have 2 here, and I have 3 in the second expression. And I'll do this step by step, and then I'll get the final answer in a minute. And now I have a base of b. When there's no power written, it's implied that it's raised to the first power. So this is going to be b to the first plus b to the first, b to the first and b to the first. And now I'm going to rewrite this and clean it up. So my simplified expression is going to be negative 14, a raised to the power of 5, b raised to the power of 2, b squared. So let's just do one property at a time until we learn all of them, and then we'll combine them all. So let's move down and look at a few of the problems here, right here. So this is just basic representation of the property. Here I have a base of x. I would write x one time, 3 plus 4, that's x raised to the power of 7. And a problem like, let's look at t. My coefficient is going to be 6, write the base of x once, and I would add 2 and 1, and that would be 6x cubed. Looking at something like h, I have negative 2 times negative 2 giving me positive 4. I write the base of x once, and I add 2 plus 1 for positive 4x cubed. And we'll look at some at the bottom of the page to start to get a little bit more cluttered, but the thought process is still the same. So looking at a problem like this. Let's see, my coefficient, I've got a negative sign here and a negative 5, so that means my coefficient is going to be positive 5. I write the base of a one time, and I add 4 and 2 for 6, and I write the base of b once, and I have 1 plus 3, which is 4. And let's do one more together. Negative 4 times negative 3 is positive 12. Write the variable a, the base a once, and I have 1 plus 1. Write the base of b once, and I have 4 plus 4. And then we'll go to the other column and do some over there, but I think this is pretty straightforward, pretty simple to do. Let's look at a few right here. Let's look at this one. So here I have positive 3 and negative 3. I write the base of a once. I don't have an a term in the second expression, so a squared remains as it is. Let's see, a b. And then I have one c here and 2 here, so that's c cubed.